We'll be looking at two questions on limiting reagents and reaction yield. In this first question, we have a chemical equation that shows the reaction between calcium and vanadium oxide. It forms calcium oxide and vanadium. The question gives us the masses of vanadium oxide and calcium, and then we are asked to find the theoretical yield of vanadium. So first of all, because we are not told whether there is any limiting reagent and which one of it is the limiting reagent, we have to first find out which is the limiting reagent. So to do that, let's first find out the moles of vanadium oxide and calcium. So moles equals to mass divided by mR. For the MR, we can look at the periodic table. So it would be 2 times for vanadium. The atomic mass is 50.942. And for oxygen, atomic mass is 15.999. So we get 8.467 moles of vanadium oxide. Let's do the same for calcium. So we will take the mass and divide by atomic mass of calcium. Now let's compare the number of moles with the mole ratio that's shown in the chemical reaction. So in the chemical reaction, we see that 5 moles of calcium would react with 1 mole of vanadium oxide. So let's write that down. And so if you have 51.150 moles of calcium, then using mole ratio, you would take 51.15 divided by 5, and it would react with 10.23 moles of vanadium oxide. So if we compare the moles of vanadium oxide that we need and the moles of vanadium oxide that we have, we see that actually we have less than what is required to react fully with the calcium. So vanadium oxide is the limiting reagent. So now to calculate the moles of vanadium that will be produced, we have to base it on the limiting reagent. So now we are interested to look at the mole ratio of vanadium oxide and vanadium. And so if we look at the reaction, we see that the mole ratio is actually 1:2. So if we calculate moles of vanadium, it will be 2 times the number of moles of vanadium oxide, which is the limiting reagent. So now that we have the number of moles, then we can find the mass of vanadium that should be produced. So the mass, or in other words, the theoretical yield, will be the number of moles and times the atomic mass. So now we have the theoretical yield of vanadium. It's 62.65. Your answer may be slightly different depending on how many decimal places you rounded to. So a little bit of difference due to rounding is fine. So now that we have the theoretical yield, next calculate the percent yield if 777 grams of vanadium are obtained. So percent yield would be the actual yield over theoretical yield. So actual yield is given here, 777, divide by the theoretical yield, and times 100%. And you should get 90.07%. Now let's look at another question that's quite similar. So here we have an equation showing the reaction between lithium and nitrogen to form lithium nitride. So you're given 12.8 grams of lithium and it's heated with 34.9 grams of nitrogen. So first of all, we don't know whether they are added in stoichiometric ratio or which one is the limiting reagent. So first we have to find this out. So let's find out the moles of lithium and the moles of nitrogen. So for moles of lithium, take the mass, which is 12.8 grams, divide by the atomic mass of lithium. So we get 1.844 moles. Let's try to find the moles of nitrogen. For nitrogen gas is N2, so make sure that for the molecular mass, you also take 2 times the atomic mass of nitrogen. So now that we have the number of moles of lithium and nitrogen, let's compare them to the moles in the chemical equation. So in the chemical equation, we see that 6 moles of lithium reacts with 1 mole of nitrogen. So the mole ratio is 6:1. So let's write that out. 6 moles of lithium reacts with 1 mole of nitrogen. Okay, so 1.844 moles of lithium would react with, and then that would be 1.844 divided by 6. Which is 0.307 moles of N2. So if we compare the amount of nitrogen that we need and the amount of nitrogen that we have, we see that the amount of nitrogen we have is actually in excess. And so lithium is actually the limiting reagent. So now let's try to find out how much lithium nitride is produced. To find the amount of product, we must base the calculations on the limiting reactant, which we have found to be lithium. So now looking again at the chemical reaction, we see that for lithium to lithium nitride, the mole ratio is 6:2. Let's write that down. Is 6:2, or you can also simplify that. It's a 3:1 mole ratio. So the number of moles of lithium nitride would be equals to the number of moles of lithium, which is 1.844 and divide by 3. So you get 0.6147 moles of lithium nitride. Now let's convert this to mass. And we get an answer of 21.4 grams. Your answer may be slightly different from mine depending on how you rounded off your answers, but a little bit of deviation due to rounding is fine. So let's put that in. Mass of lithium nitride is 21.4 grams. The next question asks you to find the percent yield if the actual yield was 5.85 grams. So percent yield would be the actual yield, which is 5.85 grams, divided by the theoretical yield, which this is the theoretical yield. So that's 21.4 grams times 100%. And you will get a percent yield of 27.3.